Okay, the second part of 7.1, 7.2 is using some of these theorems that we've discussed right down below here, and using them. So if you have parallel lines, then all these things right here are true, using them in proofs. Okay, so we know that it works in both directions too. If parallel lines, all these things are true, and if all these things are true, then you have parallel lines. Okay, so let's take a look at our first proof here. So it's given that GL is parallel to ET, and that GL is congruent to this, as well as this is congruent to GT. So you can see that all those are all congruent to each other. And what you're trying to prove here is you're trying to prove that these two are parallel to each other. And one of the biggest things that students get confused about here is trying to identify which angles are going to give you the top and bottom lines parallel to each other. And in particular, it's the alternate interior angles on a diagram like this. Students think that these two angles will give you the top and bottom parallel, but hopefully you can see that if I were to trace it out and you trace out the top side and the bottom side and see that this is a transversal here. Hopefully you can see that this angle right here, let's try a different color here, to this angle right here and this angle right here are really the angles that you need in order to show that GE is parallel to LT. So let's see if we can get there using what we know about writing proofs. So if I start out with GL parallel to ET, then I know that because of alternate interior angles, and we'll show that the alternate interior angles are going to be right here, I know that angle LGT is going to be congruent to angle ETG. That's going to be, if you have parallel lines, then the alternate interior angles are congruent. And then I can say these given information right here is going to be given. I know that GL now is going to be congruent to ET because of transitive property. And I know, of course, that GT is congruent to itself. That, of course, is just a reflexive property. So now I have side angle side showing that the triangles are congruent to each other. So triangle LGT is congruent to triangle ETG by side angle side. That comes from steps, what is it? Steps 4, 5, and 2. Okay. And now we can jump to what we were trying to show earlier, which was that these two angles are congruent to each other. And we know that those angles are congruent to each other by CPC/DC, so angle EGT is congruent to angle LTG using CPC/DC. And now, because of those angles being the alternate interior angles for those two sides, I can say that those two sides are parallel. GE is parallel to LT because if the alternate interior angles are congruent, then I have parallel lines. Okay, so that was kind of an interesting proof in that we had this going on here where the if parallel, then the alternate interior angle is congruent, and then we had just the converse of that down at the bottom, so we went the other direction. And it was interesting because we had to identify the correct alternate interior angles matched up with the correct pair of parallel sides. Okay, and the best way to do that, again, as a hint, is to actually trace out so you can see the Z and you can identify where the parallel lines are. All right, let's move on and do a couple more proofs on the back side. Okay, here we are on the back side. Let's try proof number 2 here. So it says that this side is parallel to this side, and it also says that this is parallel to this one. Okay, a little bit hard to see because the diagram's kind of odd there. It also says that you have a trisected segment here, so this is congruent to this, which is congruent to this. That just means that all the segments are congruent to each other. Okay, let's see if we can identify some things that will help us here. We're trying to prove that SH is congruent to FR, so if I could just get those triangles congruent to each other, then I know by CP/CTC I can get SH congruent to FR. And hopefully you can see here that this angle is going to be congruent to this angle here. Those are congruent because of the F shape. So if you can maybe see that if I trace this out here all the way to here, it's going to be a very skinny backwards upside down F shape. And by the same token, if I look at the blue parallel lines, the ones that I marked with blue, that these two angles are going to be congruent to each other right here. So this one and this one. And again, those are going to be forming an F shape, so those are also corresponding angles. So really here, I'm going to go with this. And the key step really is that angle H is congruent to angle FRK, and you know that angle SAH is congruent to angle FKR. Both is going to be because if I have parallel lines, then the corresponding angles are congruent. Okay, then the rest of it is just, you have the trisected lines, and then the triangles are going to be congruent by, looks like angle, side, angle, and then CP/CTC will get me to my proof statement. Okay, let's try one more. Let's try problem number 3 here. Or I guess it's problem number 5. Not sure what happened with my numbering there, but anyway. I know that EA is parallel to DB, and EA is congruent to DB, okay? And B is a midpoint of AC, so I know that these are congruent to each other. And you want to prove that these are parallel. So I'm trying to prove that these lines are parallel to each other. Okay, so let's take a look at, again, the first two parallel lines, and it looks like I can come up with an F shape here where these angles are congruent to each other because of corresponding angles. So I can definitely say that if I have parallel lines, then the corresponding angles are congruent. Okay, and I know that I got AB congruent to BC because it's a midpoint, and I also have this, that's given. So I know that the triangles are going to be congruent to each other by SAS. So now the tricky part is you have to kind of working backwards here. You now want these two to be parallel to each other, and the best way to get that is if I can prove that this angle is congruent to this angle right here. So these two angles are congruent to each other. And we know those are congruent because of CP/CTC. Then I could say that they're parallel because those are corresponding angles. So angle EBA is congruent to angle C because of CP-C2C, and now I can say that these are parallel to each other because if corresponding angles are congruent, then I have parallel lines. Okay, so hopefully that'll get you started on proofs. Good luck with that, and don't forget to ask me questions if you have any questions. Okay, take care.